Hey, what's up, Franklin West? I'm back again talking about a cylinder. This time we're going to find the volume of that cylinder. I have a different can of soup. We've got some chicken noodle here, and that's because we ate the tomato can for lunch. So we're talking about how much would it take or how much capacity is in this shape that we can fill with a volume. Volume is a three-dimensional concept. So it's a length, a width, and a height. Basically, depends on the shape that you're talking about. And so we've got three dimensions. So if we're working in centimeters as our length, then that'll be centimeters times centimeters times centimeters, which gets you centimeters cubed. The interesting thing about centimeters cubed is it's no longer just a linear component, it is a volumetric component. And so now we've got a volume here. And 1 cubic centimeter, 1 cm cubed, is the equivalent of 1 milliliter, which is a unit of volume measurement in the metric system. I tried to find a can in my cupboard that had milliliters, but because we're in good old America, we've got ounces here. So I'm not going to go into conversions of milliliters to cubic centimeters and from milliliters to ounces in order to link this all together. But just know that if you have three dimensions that you're multiplying together, you now have a volume. So some container that you can then fill with something. So that is what we're going to look at today. So I said three dimensions, and that is the first two dimensions come from this top circle. You don't have to consider both top and bottom in this case like you did with surface area. You just need one of them because you want to actually just imagine a paper thin equivalent of this circle. So it's the same dimensions, but it's super, super thin. Okay, so let's find the area of that. Because it's area, that's two dimensions. So already we're in two dimensions there. The third dimension comes from the height. So imagine enough paper thin circles to fill this height. There's our third dimension. So if you just find the area of the circle on top and multiply it to the height of your cylinder, you'll have your volume. Here, I'll show you. All right, let's jump into finding the volume of a cylinder. So here we have some similar elements compared to what we were working with surface area. If you saw that video, I have the same reference of information to help us here. And we've got a cylinder where we can isolate out the two geometries hiding within here. So the circle that is existing on top and bottom is here. And the sides of the cylinder, if you can slice it down and then unroll this flat, you will generate the rectangle. Okay, so in this case, we're looking for volume. And volume is, like I said before, three dimensions. And there are two dimensions hiding within the circle. So the first thing we need to do is we have to calculate the area of the circle. That's a given for sure. And so we're going to use this formula here. That is the area right there, more likely, is the area of a circle, where the area of a circle is pi r squared. And so down here in green is where we can start to get some information. Here's the root to our problem here. Find the volume of a cylinder with a height of 10 centimeters and a diameter of 6 centimeters. So this time I did create the shape I was trying to create. And so let's form a key for this specific problem. This step I always recommend we do is lift out what is given to us so that we can identify what it is we need to find. So we're given the height is 10 centimeters. So that is here, 10, and that matches right here in that shape of the rectangle that represents the sides of the cylinder. We're also told the diameter is 6 centimeters. Now, if you're paying close attention to the last video, the area of a circle, that formula does not include the diameter. It's all about the radius. And so this is why you have to know the relationship of diameter to radius. And because the radius is half the diameter, what we have hiding in here, if we know that the diameter is 6 centimeters, well then the radius must be 3. Okay, so sometimes these problems don't give you all your information straight out. You have to kind of think about the meaning of the information they gave you in order to uncover the parameters that we need. So now we have the radius is 3 centimeters in length. The area of that circle is, if we use that formula, pi r squared. So there's pi times our radius, which is 3, and we square it. And this should get us 9 pi. And like last time, we don't want to bother calculating what the value of 9 pi is until the end, because we don't want to deal with really long numbers that we have to keep track of or risk over rounding throughout our steps. So we'll leave it there for now. So in the segment before, I really wanted you to think about this imagination of a wafer thin circle that is 9 pi in area. Imagine a bunch of those circles, repeating amounts of those circles, going from bottom to top, stacked upon themselves. And together that stacking creates the height that is 10 centimeters. Okay, so hiding in this, and actually I should put this is centimeters squared, right? Because it is 3 centimeters times 3 centimeters here, which gives us our 9 centimeters squared. There's 2 dimensions accounted for already there, and we need the third. So let's imagine enough of these circles stacked on top of each other to generate a height that is 10 centimeters. And so now we take that 10 and we're going to multiply that height times the 9 pi. And I will put centimeters squared here, and this is just 10 centimeters, right? So what will that equal? Well, the rules of the numbers are the same. So even though I've got all this other notation in here, 10 times 9 is still 90. I have the pi that's represented there. And then centimeters times centimeters squared gives us centimeters cubed. There are 3 dimensions there, 3 powers, and that is what gets us the volume of this cylinder. So just like last time, now I would say let's take this 90 pi and plug that right into a calculator. So know where your pi button is. So I'm going to hit 90 pi, and I'm going to get a big number that needs some rounding. And so this is going to get us 282.74. Your teacher will tell you, or the problem directions will tell you how much to round. And so I'm just arbitrarily deciding to round to 2 units here past the decimal point, or 2 digits past the decimal point. So we have about 282.74 centimeters cubed, and that is our final volume here. So can you pull together the equation based on what we did here? So think about what we did. We did the area of a circle. And so what was the area? Excuse me. It was pi r squared. That alone represents the area of a circle. And we multiplied that times the height of the cylinder, which is h. And this right here is the formula for finding volume of a cylinder. Well, I hope you found that video to be helpful for what you needed. Never hesitate to reach out to let me know how you're doing and what topics you would like to see next. And as always, do your best, get your work done. You're all wonderful people. Have a great day.